Okay, technology. We have good enough time to start. Okay, so just to go back a little bit for the video recording sake. So we are going to look at Friday is going to be our catch-up day. So I'm not going to rush the concept that we have over here, which is absolute value inequalities. I'm not going to rush that one because on Friday we're going to be doing that. And then we have actually 3 days of a review before our test. So just for time's sake and for clarity's sake, we are going to focus only on linear inequalities for now. And after that, we're going to, time permitting, we're going to look at whatever that we go. All right, linear inequalities. Inequalities, as soon as we say inequalities, we are talking about greater sign, greater than or equal to, less than sign, less than or equal to. Again, it's like, okay, not equal to, and equal sign. Those are usually the symbols that we have. But when we say inequalities, most of the time we are referring to greater sign, less than sign, and then we have greater than or equal to, less than or equal to. If you remember from uh, elementary school, or a way to remember, it would be the bigger the mouth opens to the bigger side, right? So the larger one is going to be the mouth opens to that side. Depending what do we have over here, it does always. So greater than sign is on the left, less than sign is on the right side. But how does this apply and to the topic that we are covering in chapter 2? So when we are dealing linear inequalities, as I said it before, when we say linear, it starts with the word line. So we are looking at actually a line, and in a line called whatever variable. If we are dealing with x, x is known as the entire, this line is known as x. It goes from negative infinity all the way to positive infinity. So traditionally we start from 0, 1, 2, 3, and then it goes on -1, -2, -3, and so on. So when we are dealing with linear inequalities, before that, let's go with some comfort zone kind of questions. If I say solve for x, and the question is 3x plus 2 is equal to 20. What would be x? You guys can hear me, right?
Yeah, I can hear you.
Right?
Mhm.
What would be the answer?
X equals 6.
X equal to 6. How do we do it? We go ahead and say take away 2 equally, and we have 3x equals to 18. Then we go ahead and divide it by 3. Divided by 3, then my answer would be x is equal to 6. Meaning, if I'm looking at a number line, whatever, a number line called x, over here, it goes negative infinity, it goes to positive infinity. If I have, let's go ahead and say 4, 5, 6, 7, 8, my answer is when x is equal to 6. So that would be x is equal to 6, because if I plug in any number on the left or on the right, the statement would not be, it would be like, okay, true or false. Because the question says the left side is equal to the right side. So if I plug in any number, what happens? Meaning, if I plug in here for x, if I plug in 4, 3 times 4 will be 12. 12 plus 2 is going to be 14. 14 equal to 20, that would be false. If I plug in 7, 7 times 3 is 21. 21 plus 2, it would be 23. So is 23 equal to 20? False. So the only one that satisfies this equation, it would be when x is equal to 6, because 3 times 6 is 18. 18 plus 2 would be 20. Then is 20 equal to 20? That will be true. So when we are trying to answer our questions, if it is equal to, there is only one answer. When we were dealing with absolute values, we were looking at 2 answers. But when we are looking at linear inequalities, the same question, I'm just going to change a little bit. This time I have 3x plus 2 is greater than 20. Or let's go ahead and say 3x plus 2 less than or equal to 20. So 2 different questions. So the steps are going to be the same, but at the end, my answer is going to be one answer, or what type of answers am I going to get? So first thing first, let's go ahead, get rid of 20. You get rid of 2 equally from the left and the right. So we have 3x is greater than 18 divided by 3 divided by 3. Then we have x is greater than 6. So what is greater than 6? How many numbers are there? So if I'm looking at that, just for the sake of understanding, if I'm looking at the number line called x, I have 6 over here. Let's go ahead and say 7, 8. It goes to positive infinity. On this side, it goes to negative infinity, and I have, let's say, 5, 4. So what is my answer? My answer says x is greater than 6. X is greater than 6 would be 10 is greater than 6, 15 is greater than 6, 500 is greater than 6, 5,000 is greater than 6, 5 million, a billion. Any number that is greater than 6, it would be acceptable, including, which means if I am looking at the number 6, technically number 6 is right here. Number 6 is right in the middle right there. So anything greater than number 6 is acceptable. Meaning, if I say right here, let's go ahead and say like 6.5, it's still greater than 6. If I get closer, it's 6.1 is greater than 6. 6.01 is greater than 6. 6.00001 is greater than 6. So any number that is greater than 6 is acceptable. Meaning, if I plug in any number on the right side of 6, it would be okay. But anything that equal to 6, 6 is not going to work, because if I plug in the number 6 over here, what happens? 6 times 3 would be 18. 18 plus 2 is 20. Is 20 greater than 20? False. That's not going to work. So number 6 is not acceptable. What about, let's go ahead and say 7. 7. 3 times 7 is 21. 21 plus 2 is 23. Is 23 greater than 20? That is true. So that is acceptable. So any number that I plug in on this side would be acceptable. But on the left side, let's go ahead and say 5. 5 times 3 is 15. 15 plus 2 is 17. Is 17 greater than 20? That is false. So on the left side, I'm not going to include. So my answer starts from where? My answer starts, careful over here, the way we are going to be doing. Let me use a different color, in the green. So the answer is, I can get as close as the number 6. We use a parenthesis to show that. And my answer goes all the way. Everything on the right side of 6 is my answer. So from close to 6 all the way to infinity. Infinity is always another parenthesis. So my answer is going to be from 6 all the way to positive infinity. And we will look at interval notations, how to write this one. So it's going to be from 6 all the way to positive infinity. It will be my answer. On the right side, the same type of question. The numbers are the same, but our answer will be a little bit different. So if I go ahead and subtract 2, equally subtract 2 from left and right, we have what? 3x is less than or equal to 18. Then we go ahead and divide by 3, divide by 3. Then I have x is less than or equal to 6. So if I'm looking at the number line, help. On the number line, that's called 6. So I have 5, 4, negative infinity. I have 6, 7, 8, 9, and so on. And it goes to positive infinity. So this one says x over here. It says x is what? Less than 6. What is less than 6? Anything less than 6, it would be 5, 4, 3, 0, negative numbers. All of them are less than 6. What about the number 6 itself? It says less than or equal to. Since it says less than or equal to, then I can accept that answer also. Meaning, if I plug in here, number 4, 3 times 4 would be 12. 12 plus 2 would be 14. Is 14 less than or equal to 20? It is less than. That is acceptable. If I say negative 5, negative 5, 3 times negative 5 would be negative 15. Negative 15 plus 2 would be negative 13. Is negative 13 less than or equal to 20? Yes, it is less than. So this is also acceptable. But on the right side, what about 7? 7 would be 3 times 7 is 21. 21 plus 2 would be 23. Is 23 less than 20? That would be false. So any number on the right side would be rejected. But when it says equal to, I have to look at that number also. 3 times 6 is 21. 21 plus 2, sorry, 3 times 6 is 18. 18 plus 2 would be 20. Is 20 less than or equal to 20? Yes, it is equal to. So this also is acceptable. In other words, if I draw my line over here, so if I have my line over there and we say, what are the numbers that are acceptable? The numbers that are acceptable are any number on the left side is acceptable. Because if I plug in any number from the left side, it gives me a true answer. But what about the number 6 itself? Number 6 is also included. So that would be, now it's going to be a bracket because it is included. If it is equal to, it becomes a bracket. And infinity would be always a parenthesis. So my answer is going to be from negative infinity all the way to the number 6. Number 6 is bracket, and this one would be a parenthesis. So we have these 3 types of answers, which is the first one is going to be called inequality form. The second one is going to be graphing form. And the third one is going to be known as interval notations. But just for the sake of that, I'm going to explain how many different ways that it can be written. We are going to look at that. But at the same time over here, is this clear what we are just doing so far? If there's anything that's not clear, please let me know.
It's clear.
I got a question. So for the last part, the box out thingy, is that like you put a final answer? So you pretty much, so like the word problem on top, pretty much that's the setup.
Yes, but I'm just going to explain the 3 different answers. The first one Let me see if I can squeeze it a little bit. Okay. I'm going to clarify this one, okay? Just so above, below, above in the middle, and below. So on above, which means over here, right here. So this portion is known as my answer in inequality form. In the box, it is my answer in graphing form. On the bottom, it is called interval notation. So we have three types of answers, Heather. So if the question says leave your answer in a graphing form, which means you have to show me by shading the graph. Does that make sense? If it says leave your answer in inequality form, then it would be the first one using x is greater than or x is less than, whatever the equation was, that would be my answer. If it says leave your answer in interval notations, then it would be the bottom one. That's the way we answer using the brackets, and parentheses is the one that we're going to leave our answer.
Okay.
Does that make sense?
Yeah, it makes sense.
So these are the three different answers, but I'm going to explain that one step by step. Da-da-dee-da-da-da. I can insert a table. Insert a table. Yeah. Okay, I'll try to be as clear as possible here. So interval notations. Okay, so let's go ahead and say interval notations. Interval notations, some of them, there are going to be, should I use letters? Let's go with numbers. If I say 5 and infinity, infinity is always a parentheses. Let's go ahead and say this. So if this one is given like this, as a graph, it would be the number that I'm only interested would be the number 5. The other numbers are going to be negative infinity, positive infinity. I don't care about 0 because 0 is, yes, we want to be cute. We want to put the 0, 1, 2, 3 negative numbers on the left, positive numbers on the right. but let's just focus on the number that is given. We have 5 and infinity, so always 5 would be the number that we are interested. It would be right in the middle. So it says between 5 to infinity is my answer. So in a graphing form, my answer would be, this is the portion of the inequality that we are interested. So if I'm in a graphing form, my answer would be parentheses, parentheses. So in inequality, it says, if you want to think about it, the shaded area is my x. So x in reference to 5, is it greater than or less than? So x is, and we have 5. So what should be in the middle? So if think of a number on the shaded area. Let's go ahead and say 10. Is 10 on the shaded area? Yeah. So 10 is what? 10 is in reference to 5 would be what? 10 is greater than 5 or 10 is less than 5? It should be 10 is greater than 5. So my answer would be 10 is greater than 5 would be the inequality form. The same type of question, but just changed a little bit. And instead of 5 comma infinity, and this time we have a bracket. Again, I don't care about other numbers. The only number I'm interested is the number 5. On the left, I'll put negative infinity. On the right, I'm going to put positive infinity. So what is shaded? It is, this portion is shaded. So infinity is always a parenthesis, but 5 is a bracket. Meaning, again, if you want to think about it, the shaded area is x. X is in related to 5. What is it? If you are thinking about a number, as I said earlier, 100. Is 100 greater than 5? Then that is true. So it would be 100 greater than 5. But now I have to look at the bracket. The bracket tells me it is also what? It is included. I know this is going to be on a video, so take your time and watch it. But I'm just going to go. If I'm rushing, please let me know. That way we can go ahead a little bit slower. Another one from negative infinity. Let's go ahead and say 10. Negative infinity, positive infinity, the number I'm interested is 10. So it says the shaded area is what? Between negative infinity and 10. So I'm going to shade this portion. So 10 is a parenthesis, means parentheses, it means it's not included. So it's going to be parentheses, a parenthesis for the infinity. As a reminder, if the shaded area is x, x in relation to 10, what is it? So if I say 50 is what to 10? So 50 would be greater. It's not a greater side, and 50 is on the other side. But if I pick on the left side a number, let's say 0. 0 in reference to 10 would be 0 is less than 10. So it would be less than 10 would be my answer. So the inequality form would be in that way. The graphing will be in the middle, and then the interval notation will be on the left side. So similar question, but this time let's go ahead and say from negative infinity, and let's go ahead and 15, it doesn't matter. Negative infinity, positive infinity. In the middle, I'm only interested with the number 15. So it says the left side, the interval notation tells me which one to shade. It says shade between negative infinity all the way to the number 15. Infinity is always a parenthesis, but 15 is a bracket. So I have x in relation to the number 15. So if I'm thinking of any number, let's go ahead and say 2. 2 is something to 5. So it is going to be 2 is less than 5. 2 is less than 15. That would be true. But the bracket, I have to remember, the bracket tells me that's going to be equal to. So less than or equal to 15 would be the proper way to write it. So there are a little bit considering next class topics, there are some that are going to be in the middle and facing outside. So the middle ones will be, let's say, -2 and 7. So if I'm looking at the number line, negative infinity, positive infinity. The other two numbers that I'm interested are -2 and number 7. The problem tells me to shade from -2 to +7, and the left side, it tells me -2 is not included. The right side, it says +7 is not included, and that will be the graphing form. So the graphing area is x. So x on the left side, I have -2. On the right side, I have 7. So if I'm looking at those two numbers, what sign should be in between? The sign that in between should be, if I think of a number, let's go ahead and say a number between -2 and 7, let's say 5. So it would be -2 in relation to number 5 would be less than. And then again, I'm thinking of a number here, 5. So -2 is less than 5, true. 5 is less than, also what? It would be 5 is also less than 7, and that would be the proper way to write it. So there are some questions like this that we're going to see next topic.
Wait, excuse me, I have a question.
I'm listening.
How come you didn't put the bracket by like the 7?
Because none of them are, 7 is not included. -3 and I don't like 8. Let's go ahead and 10. So if this was like this, right? I don't know if it shows on your screen as a bracket.
Yeah, I can see it.
Right? But the previous example, both of them were parentheses. Got it? So this one was, both of them they were parentheses. Over here, the left side is parentheses. The right side is what? A bracket, right?
Yeah.
So now, again, negative infinity, positive infinity. My two numbers are -3 and +10. So it says shade between -3 and +10, right? But now -3, it says not included, is going to be parentheses. Number 10 is bracket, it is going to be included. So if I try to write this one using inequality form, on the left side of x, I have -3. On the right side of x, I have number 10. So this time, again, it's going to be less than. If the numbers are in order, which means smaller number on the left, the larger number on the right, it's always less than. If you pick a number, then that will be a best way to check will be, you can say, oh, let me see if this number is true. You can go ahead and say, let me say between -3 and 10. I'm going to say like, okay, 2. So if I plug in 2, what happens? -3 is less than 2. That's a correct symbol. 2 is less than 10. That's also correct symbol. But this time on the left side, it is parentheses. So less than is okay. On the right side is a bracket. So this should have been not only less than, it should have been less than or equal to. Does that make sense?
Yeah. Thank you.
You're welcome. And another one, it will be in the same area. Sometimes we have both sides are going to be, both sides, the left and the right are brackets. If the left and right are brackets, negative infinity, positive infinity. So my two numbers are, I have number 4 and 17. And it says shade anything that is in between 4 and 17. But this time, the left side, it is what? Bracket. The right side is also what? Bracket. So if I go ahead and do my x, x is the shaded area. So x in relation to the number 4 and to the number 17. If I plug in any number in between, let's go ahead and say number 10. If I plug in 10, it would be what? 4 in relation to 10 would be 4 is less than 10. 10 is in relation to 17 would be 10 is also less than. But by looking at the original information that's given, both of them are bracket, then it would be what? Less than or equal to, less than or equal to. Does this make sense a little bit?
Yeah.
Mm-hmm. And
Yeah, I'm fine for right now.
Okay, thank you.
So with those three categories, so let's just say like if a problem it shows like the first category.
First category, hold on, Heather.
Yeah.
Just let me come back and let's call them A, B, C, D, E, F. That way I know exactly which one are we talking about.
The F. Well, for example,
Okay.
so let's just say like the first box of F.
Mm-hmm.
And then it said, okay, find this equation or whatever, and then you have to do it as the graph as well, and then like two answers.
At this time I'm just explaining how the relationship, how to write them from interval notation to inequality, from inequality to graphing form and so on. But when we are given questions, sometimes there are going to be they're going to fall in one of those scenarios. Excuse me. So just let me give you an example, and then you see if this makes sense. So let's say as an example, right here, let me stay right here. I have 5x plus 7 is equal to, let's friendly number. Let's go ahead and say greater than or equal to 17, right? So if I'm trying to solve this problem, the first thing that I do, I treat it like an equal problem. So take away 7, sorry. I'm thinking about the answer. Take away 7 equally from both sides. And I have what? 5x is greater than or equal to 10. Then I divided by 5. I divided by 5. So my answer would be what? It would be x is greater than or equal to 2. So this is my answer. If the question says write your answer in inequality form, I am done. This will be my answer in inequality form.
Okay.
If it say leave your answer in a graphing form, then I would draw my line right under it. So negative infinity, positive infinity, and I have the number 2 right in the middle. I do not care about any number before, after. My focus is number 2. Now, some of it should be straightforward, but most of the time, if you want to be a little bit careful, use test points. Again, the one that I'm going to be doing in red, it is for us to see if I'm on the right track or not. So this is what I call test points. So if I'm not sure which side to shade, I have the number line is cut before 2 and after 2. So I'm going to take 2 test points. On the left side, I'm going to take, something, if 0 is available, I'll take it. If 1 is available, I'll take it. If not, then any number would do. But number 1 times any number is the number itself. 0 times any number is 0, so I don't have to depend a lot on a calculator, so to speak. On the right side, you can go crazy, doesn't matter, but something friendly would be okay. Let's go ahead and say 10. So I'll check those 2 numbers. So on the left side, I have 10. So, I have 0. If I plug in 0 here, what happens? 5 times 0 would be 0, plus 7 would be 7. Is 7 greater than 17? True or false? Okay, one more time. I have 0. 0, when I plug it for x, it becomes what? 5 times 0, it becomes 0. 0 plus 7 becomes 7. 7 is greater than or equal to 17. Is that true or false?
False.
So I'm going to put here. What about 10? If I plug in 10, what happens? 10 times 5 is 50. 50 plus 7 is 57. 57 is greater than 17. Is that true?
It's true.
So the area that I'm going to be shading would be the true side. So the true side I'm going to be shading. Remember, anything that is in red, it is for me to double check what I'm doing. My answer is anything that is in black, okay? So now by looking at my question over here, it says equal to. If it says equal to, then the number is also included. Meaning over here, I have to make sure that the number 2 is a bracket, not a parentheses. And it goes all the way to infinity. So anything that is in black would be my answer in graphing form. Does that make sense?
Yeah.
And then the shaded area starts where? Heather, help me. The shaded area starts from where to where?
To
Huh?
to right. Wait,
From what number to what number is shaded?
to the infinity.
So it's going to be, look at this. The shaded area is from 2 all the way to what? To infinity. Number 2 is bracket. Infinity is parentheses. Does that make sense?
Yes.
So now by looking at that, that would be my answer in interval notations. So if it says leave your answer in a graphing format, then the second portion would be my answer. If it says leave your answer in interval notation, then would be the third one. So I like the graphing to be in the middle because it can confirm my answer. Does that make sense? So I can be sure. I don't like people jumping from inequality to interval notations. That's when a lot of people start making silly mistakes. But I'm okay if you are able to do it with no error. But I have seen enough mistakes when people are skipping the graphing format in between. Does this help a little bit?
Yes.
Okay, so let's go ahead and look at some problems. All right, what happens when we have 5 minus 3x less than all right, somebody help me. What do we do first?
I'll say subtract 5 and put it to the other side.
So take away 5 equally from both sides. And then?
I'll cancel the 5.
Okay.
And then you get 27.
What is
Another.
it? Help me. Step
Bring down the negative 3x.
first, bring down the
Oh,
3x. Okay, continue.
We divide negative 3.
Divide by negative 3. Then what happened?
The negative 3 cancels out.
Okay, negative 3 cancels out.
So x is less than negative 9.
X is less than negative 9. All right, so everybody, please pay attention here. I have 10 and negative 5. What symbol should go right in between? It should be greater than or less than.
Greater than.
It should be greater than. So please follow. If I'm multiplying this by 2, if I multiply this by 2, I get 20, negative 10. What sign goes in between?
Greater than.
Greater than. Thank you. And then let's go ahead and say, if I divide this side by 10, if I divide this side by 10, over here becomes 2, over here becomes negative 1. What sign goes in between?
It's going to be greater than.
So again, whatever I did by positive number didn't change anything, right? If I multiplied by positive number, if I divided by positive number, nothing happened. The sign remained the same. But let's look at the same numbers. This time I'm going to say greater than or less than. What goes in between? I have 10 and negative 5. So the sign was what? It was greater than. But this time I'm going to multiply this by negative 2, negative 2. Negative 2 times 10 gives me negative 20. Negative times negative, it gives me positive. What sign goes in between?
Less than.
Negative 20 is less than positive 10. Now, if I go ahead and divide this by negative 10, negative 10, negative, negative, it becomes positive. Positive 2. 10 divided by negative 10 becomes negative 1. What goes in between?
Greater than.
So what am I trying to say? If we are multiplying or dividing by a positive sign, the sign remains the same. If I are multiplying or dividing by negative, sign flips. So with that in mind, if that convinces you, over here, what do we do? Over here we say, I have to be very careful when I am seeing negative 3. I'm dividing by negative 3. If I'm dividing by negative 3, what happens? My sign over here, it shouldn't be the same. The sign should be opposite. So over here, if you want a reminder.
Oh, so we had to change the sign.
Got it?
Mm-hmm.
So when multiplying or dividing by a negative number, inequality sign flips. Does that make sense, everybody?
Yeah.
Okay, so always we need to remember that. Based on this one, we can go ahead and say, okay, fine, I have my number line. Just to look at this, negative infinity, positive infinity, and the number I'm interested in will be number negative 9. X is what? X is, if I'm reading this, it says what? X is greater than negative 9. What is greater than 9? It should be on the right side or on the left side. The numbers that are greater than negative 9, it would be on the right side. So my answer should be anything on the right side should be. And is it equal to? No. So since it's not equal to, it would be a parentheses. That will be my answer in interval notation. And sorry, in graphing format, my answer in interval notation would be from negative 9 all the way to positive infinity would be my answer in interval notation. So which means if I pick any number on that shaded area and then plug it into the original question, it should work because I am claiming the answer is supposed to be that. So in other words, let's go ahead and say, give me a number Anything from the left side and anything on the right side. Somebody. Give me a number.
-3
-3 where?
on the left side.
The left.
Ah, -3 is on the right side. Remember? -3. Then you have what? -8, -7, -6, -5, -4. -3 would be on the right side. Does that make sense what I'm saying?
No,
Yeah, I was lost.
because
Yeah.
you have the negative sign to the left.
So -9, right?
Mhm.
-9. So the other numbers are what? The other numbers over here are -8, -7, -6, -5, -4, -3, -2. Does that make sense? On this side will be -10, -11, -12, -13.
Oh, now
Got
it
it?
makes sense.
Does that make sense what I'm saying?
Yeah,
So-
now that you're rolling it out.
So
Right.
if I said any number on the left, then when it comes to negatives, large numbers, so to speak, are smaller than. I see that's not a good example. A large negative number is smaller than a small negative number. In other words, is saying if I say which one is better to be in debt, -$500 or $25. Both of them are debts, right? But 25 is better, even though it's smaller, because the other one is being buried in debt. So let's go ahead and say on the left side, if I pick -10 to check, on the right side, let's go ahead and say you said -3. If I plug these questions, these values into the original question, the one on the right should give me true. The one on the left should be false. So just let me be lazy a little bit over here for time's sake. So since I'm claiming the answer is supposed to be that, over here we are going to for x equal to -10, over here for x equal to -3. So when I plug in -10, what happens? 5, let's go lazy, paste. Okay, so we are claiming for this to be -10, for this to be -3. So once I'm plugging, I'm just going to put my question mark because I'm trying to see if that statement is true. On the left side, let's focus on the left. We have -5, negative becomes positive. 3 times 10 becomes 30, is less than 32. And then what we have, 5 plus 30 would be 35, is less than 32, question mark. That would be what? Because 35 is greater than 32. On the right side, I have 5, negative becomes positive. 3 times 3 becomes 9, less than 32, question mark. 5 and 9 becomes 14, is less than 32. This is what? So 14 is less than 32. That would be true. So that would be the side that actually that we shaded are the correct side. Is this clear a little bit?
Yes.
Okay, so I know it's going to be in the video, so just for that sake, let's do this. Compound inequality. Compound inequality means we have more than one equal sign. So if I say -3, let's go with a friendly number. Okay, it's fine. -3 is less than or equal to 2x plus 7 less than, let's go ahead and say 15. So this is known as a double inequality or a compound inequality. When we are solving this type of questions, at the end, we want the x in the middle. So which means if I'm trying to have the x in the middle, so the goal would be, I need to take away 7, take away 7, take away 7 from all sides, equally from that side, equally from that side. On the left side, I'm going to end up with negative 10 less than or equal to 2x less than 15, take away 7 will be 8. Then I have divided by 2, divided by 2, divided by 2. So everything what I do to one side, I have to do to the other side. So the middle cancels. Negative 10 divided by 2 becomes negative 5 less than or equal to x. 8 divided by 2 becomes 4. So this would be my answer in inequality form. In a graph, come on, there you go. Again, habit, negative in infinity, positive infinity. The two numbers that I'm interested are the number negative 5 and the number 4. It says x is in between. If you want, you can go ahead and do your test points. Once you do your test points, then you should be able to see if this is true or not. So again, we only shade the true side, meaning if I plug in a test point here, a test point here, a test point here, because the number line is cut into 3 places. So on the left, I'm going to say negative 10. In between, 0 is available. I'll take that one. On the right side, 4, let's go ahead and say 7. So it's known as an AND statement. I'll explain this one on Friday. AND means it has to be both sides must be true. So in other words, negative 10. Negative 10, if I plug it here, what happens? If I plug in negative 10 right there, 2 times negative 10 becomes negative 20. Negative 20 plus 7 becomes negative 14. So we have negative 3, negative 3 less than or equal to, when I plug in negative 10, negative 20, negative 13, and less than 15. So now 3 is less than 13. That is false because over here 3 is greater than 13. So that side will be false. What about if I plug in 0? 0, what happens? 2 times 0 becomes 0 plus 7 becomes 7. So we have negative 3 less than or equal to 7 less than 15. So negative 3 is less than 7, true. 7 is less than 15, true. So this is good. So this is going to be, what about 7? 2 times 7 is going to be 14. 14 plus 7 becomes 21. So we have negative 3 less than or equal to 21 less than 15. On the left side, negative 3 is less than 21. That is true. But 21 is less than 15. That is false. So because of that, this was false. Because of that, that is false. So which side am I shading? The one I'm shading is going to be somewhere in the middle. Let's go ahead and black. I'm going to shade the black side. Again, the red is only for me to know which side to shade. And by looking at on the left side, this tells me bracket less than or equal to, tells me it's a bracket. This side tells me it's going to be what? Just a parentheses. So that would be my answer in graphing form. In an interval notation, my answer was going to be the shaded area starts from negative 5 and it goes all the way to positive 4. Positive 4 is a parentheses. This side is going to be a bracket. So this is going to be interval notation. Over here we have so we have these. All right, I know we're running out of time, so let me just quickly look at before I confuse you with the homework assignments. So for the homework, we have linear inequalities, which is page 149. It says 6, 9, 13. 6, 9, 13. And after that, what do we have? 16, 19, 28. 16, 19, 28. All right.
And
You should be,
25.
all right. Okay. So not a big deal, the one on the bottom. So let's go ahead. Only the first portion is going to be our assignment because I didn't teach you guys in absolute inequality. We're leaving that one for Friday. So this portion is going to be the assignment. So it's going to be, what do we have? Just forgive me, 6, 9, 13. And 6, 9, 13, okay. So the assignment is going to be number 6, 9, and 13. 13 are for Friday. So what was that page? Page 149. Yep. Page 149, only number 6, 9, and 13 are due for Friday. And then the next one was going to be, again, you can submit it either Friday or Monday. I'm just going to send out an announcement just with this, for clarity's sake. You don't have to submit it until Monday, until everything is clear. But if as an assignment, you can do number 6 and 9 and 13. It should be clear. And the next portion will be for next class. If you guys have any question, I am here. If not, we can call this one a day. Let me stop recording. Where are you? Anybody came late?